Imagine looking at an object, right? And it is undeniably like a perfect circle.
Okay, I'm picturing it.
But then you take one step to the side, you look at it from a slightly different angle, and it just magically transforms into a perfect square.
Right, which sounds completely impossible.
Exactly. I mean, your brain just screams that it can't be both. A circle is a circle, and a square is a square. They're opposites.
Yeah, we're really wired to think that way.
But according to this brand new article we're unpacking today, not only can it be both, but if you don't accept that it's both simultaneously, you fundamentally cannot understand the universe.
Yeah, that tension, that absolute requirement to just sort of force yourself to hold two opposing ideas in your head at the exact same time, just to get a grip on reality.
Yeah.
That is the core of what we are exploring in this deep dive.
It's a huge topic.
It really is. So the article is actually published today, April 8th, 2026, by a Substack author named SpiralSeekr, and it's titled The Architecture of Duality: Oppositions in Nature and Thought. And SpiralSeekr basically puts forward this incredibly compelling argument that the concept of duality isn't just, some quirky philosophical musing.
Or like a poetic metaphor or something.
Right, exactly. It's not just poetry. It is an active structural framework, like a necessary heuristic that humanity completely relies on to decode everything. And I mean everything, from subatomic particles to the actual nature of our own consciousness.
Which is wild. And to put it in a way that always made sense to me when thinking about this, think about those old school 3D glasses.
Oh, yeah. Like the cheap cardboard ones.
Yeah, the ones they used to hand out at the movie theater where it has like one red plastic lens and one blue plastic lens.
Right.
If you close one eye and just look through the red lens, the world looks completely washed out, but in one very specific way.
Yeah, everything's tinted and weird.
And then if you switch eyes and look through just the blue lens, it's distorted in a totally different way. Red and blue are on opposite ends of the spectrum, so they seem like completely incompatible opposites.
Lovely.
But then you open both eyes, and suddenly this flat, confusing, blurry image on the movie screen just pops out at you with incredible depth and clarity.
Yeah, that's a really great way to look at it.
You absolutely need both of those opposing lenses working together if you want to see the full, complex picture. You can't just pick one.
And that requirement, looking through two different lenses to see a higher truth, it isn't just a trick of human biology. It's not just how our eyes work.
Right.
According to the first part of SpiralSeekr's analysis, it is a literal structural demand made by the physical universe itself.
Which is kind of terrifying, honestly.
It is, because before we can even begin to talk about human consciousness or, how we solve complex abstract math problems, we have to look at the very base layer of reality, the quantum level.
Right, the subatomic stuff, the building blocks of literally everything you see around you, like the device you are listening to this deep dive on right now, all the way up to the stars in the sky.
Exactly. And this is where classical physics just hits a massive, immovable brick wall.
Okay, let's unpack this, because I know classical physics likes things to be neat and tidy.
Oh, yeah. Classical physics operated for centuries on a very strict binary categorization system. Like, things had to be one or the other.
Right.
In the classical view, energy and matter behaved in one of two mutually exclusive ways. So something was either a continuous wave...
Like a ripple in a pond.
Exactly. Think of a ripple moving outward across the surface of water, distributing its energy over a wide area.
Okay.
Or it was a discrete particle, like a billiard ball, just occupying one specific measurable point in space.
Got it. Wave or particle? Never both.
Right. Because the mathematics for a spreading ripple and the mathematics for a hard billiard ball are entirely different. I mean, you cannot plug the properties of a single localized point into the equation for a spreading wave. It just doesn't work.
But the universe, when you zoom in close enough, absolutely refuses to be put into just one of those neat little mathematical boxes, right?
It totally refuses. This is the phenomenon of wave-particle duality. And SpiralSeekr points out that all matter and energy at that level exhibit properties of both waves and particles.
Both of them.
Both. The classical distinction just completely dissolves. And we really only know this because of the groundbreaking work of physicists like Max Planck, Albert Einstein, and Louis de Broglie in the early 20th century.
The heavy hitters.
Right. They realized that if you only use the particle equations, the math completely breaks down the second you try to calculate, say, how light bends around a microscopic obstacle.
Because it starts acting like a wave.
Exactly.
Okay, but it can sound like absolute magic when you first hear it. I mean, how can a physical entity be a spreading ripple and a solid billiard ball at the exact same time?
It's hard to visualize.
It really is. And the article brings up two contrasting experiments that basically force scientists to just accept this duality, right? The double-slit experiment and the photoelectric effect.
Yeah, those are the big two.
So in the double-slit experiment, scientists fired electrons at a barrier that had two tiny microscopic slits in it.
Right, and they thought of electrons as particles.
Exactly. They categorized them as particles. So they expected the electrons to just pile up in two distinct clumps on the wall behind the slits, like throwing little baseballs through two windows.
That's two piles of baseballs.
Right. But instead, the electrons created this insanely complex interference pattern on the detector behind the barrier.
Which is a pure signature behavior of waves.
Yes. It looked exactly like ripples of water passing through the two slits and then overlapping and crashing into each other.
So in that specific setup, the particle model completely fails to explain the reality of what is happening. I mean, the math of billiard balls cannot predict an interference pattern.
Not at all.
The entities behave undeniably as continuous waves. But then, you turn around and look at the photoelectric effect, which, by the way, is the phenomenon that actually won Einstein his Nobel Prize.
Wait, really? Not relativity?
Nope, it was the photoelectric effect.
Huh, okay, so what is that exactly?
So when you shine light on certain metals, the metal emits electrons. It knocks them loose.
And classical wave theory couldn't explain that, right? Because if light was just a continuous, smooth ripple of energy, it shouldn't be able to just violently knock an electron loose in the sudden way they were observing.
Right, it couldn't explain the immediate quantized transfer of energy. It was too choppy.
Okay.
So Einstein showed that the light must actually be traveling in discrete packets, or quanta, which is what we now call photons. So in this setup, the light acts as a particle. It's a little billiard ball, physically knocking the electron off the surface of the metal.
Wow.
Yeah, the mathematics of a continuous wave fail completely here. You absolutely need the math of discrete individual impacts.
I was trying to wrap my head around this dual nature earlier, where in one experiment, the entity acts like a ripple, and in another, it acts like a billiard ball. And tell me if this analogy holds up.
Let's hear it.
Imagine you have a physical object, like a 3D cylinder, say a can of soup.
Okay, a soup can. Yeah.
Now imagine you shine a light on it directly from the side so it casts a shadow on the wall behind it. That shadow on the wall is a perfect rectangle.
Right, definitely.
But then, if you move the light and shine it from the top down so it casts a shadow on the floor, that shadow is a perfect circle.
Okay, I'm with you.
Now imagine you're a flat 2D scientist who lives in Flatland. And you can only measure shadows, you can't see 3D objects, you would be incredibly confused.
Oh, absolutely.
Because in one experiment, the object is undeniably a rectangle. And in another experiment, it is undeniably a circle. And you and the other scientists might argue endlessly about whether it's a rectangle entity or a circle entity.
Yeah, they form rival schools of thought.
Exactly. But the actual truth is, to understand its true higher dimensional shape, the 3D cylinder, you have to accept both of those shadows as valid simultaneous truths. You need the duality to prove the true shape.
What's fascinating here is that your analogy isn't just a clever metaphor. It illustrates exactly why physicists had to fundamentally restructure their mathematical understanding of reality.
Because the universe is the soup can.
Exactly. Your cylinder analogy captures the underlying mechanism of quantum mechanics perfectly. Nature actively forces us to abandon classical, either binary thinking, because reality is simply higher dimensional than our classical measurements allow us to see.
But we just love binaries.
Oh, we love them. Our brains evolved to make very quick, definitive judgments just for basic survival. Is this safe or dangerous? Is it light or dark? Up or down?
Friend or foe?
Right. But the foundational layer of the universe operates on a dualistic reality.
Yeah.
You cannot get a complete description of quantum phenomena without accepting that complementary opposites are simultaneously true, depending entirely on the angle of your measurement.
So if the very atoms that we are made of refuse to be categorized as just one thing, it makes perfect sense that when human thinkers started studying themselves, we hit the exact same wall.
Oh, definitely.
We seamlessly transition from the physical duality of atoms to the philosophical duality of human existence, the big one, the mind and the body.
Yeah, SpiralSeekr uses this quantum parallel to transition right into metaphysical and epistemological dualism.
Which is a mouthful.
It is.
Sure.
But basically, this is where philosophy attempts to take the overwhelming, messy complexity of the human experience and divide it into distinct, irreducible categories.
To make it manageable.
Exactly. And the most famous example of this in the Western world, as the text notes, is René Descartes in the 17th century.
The classic, I think, therefore I am philosopher.
That's the guy.
So, like, if you're listening to this deep dive right now while you're running on a treadmill, Descartes would essentially say that the part of you that is processing the ideas we're talking about and the part of you that is physically making your legs move and burning calories are two totally different things.
Completely different. He formalized that exact split into what we now call mind-body dualism.
Okay.
So Descartes argued that human beings are composed of two fundamentally different substances.
Okay.
He categorized the mind as res cogitans, which means a thinking entity.
Res cogitans.
Right. And in his framework, the mind is entirely non-physical. It has no weight, it has no length, it doesn't occupy physical space at all. It is just the realm of pure thought, logic, and consciousness.
And then there is the body, which is just, meat and mechanics.
Basically, yeah, he termed the physical body res extensa, so a physical, spatially extended entity.
Because it extends into physical space.
Exactly. It has mass, it takes up space, and most importantly, it obeys the deterministic mechanical laws of physics. And Descartes drew a hard, permanent boundary between the two of them.
Like a brick wall.
Yes. The mind is the ghost, and the body is just the machine that it temporarily haunts. It is a strict, clinically antagonistic division.
Okay, here's where it gets really interesting, and honestly where I kind of have to push back on Descartes a bit.
Okay, go for it.
Because his strict divorce between the mind and the body shaped almost all of modern Western thought. But it just feels so isolated. I mean, is that really how we experience life on a daily basis?
You're saying it feels a bit disconnected from reality.
Yeah. And SpiralSeekr actually contrasts Descartes with Eastern philosophy, specifically the concept of yin and yang, because Descartes tells us our mind and body are totally divorced substances. But anyone who has ever had a panic attack or felt their stomach literally drop when they received bad news knows that the mind and body are constantly talking to each other.
Right, the physiological response to a mental state.
Exactly. In the yin and yang model, opposites are not an antagonistic division. They aren't rivals separated by a big wall.
Right. They are defined by their interdependence.
Yes. Wait, not just interdependent, but mechanically linked to each other. It's less of a strict wall and more like a thermostat and a furnace in a house.
Oh, like that.
One reads the temperature of the room, the other actively heats the room, but you literally cannot define the climate control system without both of those components talking to each other continuously.
Right, they feed into each other.
Yin contains a little bit of yang, and yang contains a little bit of yin. Viewing our physical and mental states as an integrated system, like a constant feedback loop, just feels so much closer to the actual reality of being a human being.
If we connect this to the bigger picture, I hear what you're saying.
And
the holistic appeal of yin and yang is undeniable, especially in modern psychology. But I'd say don't discount Descartes so quickly. Viewing the mind and body as a unified, flowing system is beautiful, yes. But Descartes' strict clinical separation is exactly what allowed the scientific revolution to actually happen in the West.
Wait, really? How so? Just by ignoring the holistic part of us?
Sort of. By creating a necessary heuristic firewall.
A firewall?
Yeah. So in the 17th century, dissecting a human body or studying anatomy was incredibly dangerous because religious authorities believed the physical body and the divine soul were completely intertwined.
Oh, so if you cut open a body, you were messing with the soul.
Exactly. It was taboo, heresy even. But by legally and philosophically separating the mechanical body from the immortal mind, Descartes gave early scientists permission.
That's a huge loophole.
It was a massive loophole. He basically said, hey, the soul is safe over here in the mind. We're just tinkering with the biological machine. That allowed them to study anatomy, blood flow, and medicine without being accused of dissecting the human soul. Without that harsh clinical binary, modern medicine might have been delayed for centuries.
Okay, wow. That is a fascinating angle. I had not considered the political or historical utility of that strict division at all. It was literally a conceptual architecture built specifically to bypass a cultural roadblock.
Exactly. Both frameworks, yin and yang and Cartesian dualism, are necessary attempts by the human brain to process reality.
Right.
Descartes provides a tool for analytical deconstruction, taking the machine apart to see how the gears work.
And the yin and yang framework provides a tool for synthetic understanding, seeing how the system behaves as a whole.
Spot on. We need the dualistic framework in whatever form it takes just to handle the sheer volume of data that existence throws at us.
We're constantly trying to build a map of a territory that is just way too big to see all at once. So we draw the map in two different ways to try and capture everything.
That is exactly it.
So we've seen how duality dictates the physical matter of the universe, right? And how it dictates human philosophy and self-perception. But SpiralSeekr's article takes us one massive step further.
Yeah, into the abstract.
Right. We move from the messy, tangible world of atoms and human thoughts into the absolute purest language humanity has ever invented. Mathematics.
Yes. And here, duality shifts from being just a description to becoming an active tool.
This is where things transition from like abstract ideas into incredibly precise, actionable tools.
Exactly. In pure mathematics, duality stops being just a descriptive label. We slap on things to make them easier to digest. It becomes an active, incredibly powerful mechanism for actually solving problems.
So how does that work?
SpiralSeekr points specifically to structural symmetries in mathematics. The article gives prime examples from linear algebra, stating that every vector space has a corresponding dual space.
Okay, which, if you aren't a math major, sounds incredibly intimidating.
It does sound like jargon.
So what does a dual space actually mean functionally?
Okay, think of the original vector space as a collection of physical objects, like big blocks of different shapes and sizes of wooden blocks.
Okay, I've got my blocks.
The dual space isn't a second collection of blocks. It is a collection of all the possible measurements you could take of those original blocks.
Oh, interesting.
Right. It's the rulers, the scales, the calipers. The objects and the measurements of those objects are mathematically bound to each other.
So they're paired.
Exactly.
Yeah.
Whatever mathematical truth applies to the space of the objects has a perfectly mirrored mathematical truth in the space of the measurements.
That is wild. It's like the math is baking its own reflection into its own structure.
Yeah. And linear algebra does this with dimensions. But the concept becomes delightfully mind-bending when we look at the second example SpiralSeekr provides.
Projective geometry.
Right, projective geometry, which deals with the relationships between fundamental shapes. And it has a built-in rule of duality.
Okay.
This rule dictates that any valid mathematically proven theorem involving points and lines remains perfectly valid if you simply swap the words point and line in the theorem.
Wait. I want to make sure I understand this. You literally just swap the vocabulary. You don't have to change the equations or the numbers.
You literally just swap the terminology. Let me give you the foundational axiom.
Please do.
In geometry, the basic rule is any two distinct points define exactly one line. If you draw two dots on a piece of paper, only one straight line can connect them.
Right, basic geometry. I remember that from high school.
Now swap the words point and line.
Okay. Any two distinct lines define exactly one point.
Yes, which is the mathematical way of saying that two non-parallel lines intersect at exactly one point.
Oh, wow.
Both statements are equally true. And this scales up to insane levels. If you spend years of your life proving a massively complex, multi-page theorem about the behavior of points and lines, you instantly get a second, equally true theorem for free just by flipping the words.
So what does this actually mean for someone trying to solve a problem? Because it sounds a bit like translating an incredibly difficult, almost impossible riddle from English into French.
Well, I like where this is going.
Like, imagine you are struggling with a complex logic puzzle in English for weeks, getting absolutely nowhere. But the moment you translate the exact same puzzle into French, you suddenly realize that the answer actively rhymes in French.
Right.
The phonetic structure of the new language just makes the solution blatantly obvious. So you solve the riddle in French, and then you just translate the solution back into English. Does that track?
This raises an important question. And your analogy captures the exact mechanism of why mathematicians care so much about dual spaces. Structural symmetry acts as a secret backdoor.
A backdoor.
Yeah. Mathematical problems can be notoriously stubborn. You might be staring at a geometric proof or maybe a complex routing algorithm for a huge computer network, and in its original structure, it's English. Using your analogy, it is completely impenetrable. It is computationally too heavy to solve.
It's just a wall.
Right. But because you know a dual space exists, you just map the problem into its dual form.
You pass it through the abstract mirror.
You pass it right through the mirror. And very often, the relationships and rules in that dual space are just simpler. The solution becomes readily apparent. So you do the heavy lifting of the dual space, find the answer, and then translate that answer back into the original space.
That feels like a cheat code.
It really does. The duality isn't just a philosophical observation anymore. It is a mechanical shortcut for breaking through mathematical roadblocks. At the foundational level of math, Structures are defined by relationships, not objects. A point is just a relationship between lines, and a line is a relationship between points. The duality allows you to exploit that structural symmetry.
It's like having a parallel universe where the physics of gravity work totally differently. So when you encounter a giant boulder in our world that you can't lift, you just pop over to the parallel universe, easily lift the boulder with one hand, walk 10 feet, and pop back into our universe with the obstacle cleared.
That is the perfect way to visualize abstract mathematical problem solving.
Well, bringing all these threads together, looking at SpiralSeekr's ultimate conclusion today. We started at the literal bottom of the physical universe with quantum mechanics, examining how light and matter refuse to be just one thing.
Wave and particle.
Right. And then we moved through human philosophy, looking at how thinkers like Descartes built necessary firewalls between the mind and body just so we could study ourselves medically.
Exactly.
And finally, we ended in the pure abstraction of mathematics, where duality is this incredible secret backdoor to solving the impossible. The through line here is undeniable. Duality is the ultimate necessary mechanism for modeling complex systems.
It really is. It is the universal framework that allows for the categorization and analysis of interdependent properties, no matter what field of study you are looking at.
Whether you are a quantum physicist tracking the behavior of electrons, or a philosopher pondering the nature of your own consciousness, or just a mathematician trying to optimize a geometric proof, you rely on these paired oppositions.
Absolutely.
And honestly, this has a very direct, practical application for you listening right now in your daily life.
Oh, for sure.
Because if this is how the literal universe solves its most complex problems, it is a pretty incredible model for us to borrow. Think about the last time you felt totally stuck. Maybe it was a massive project at work that just wasn't coming together, or a system you were trying to build that kept breaking down.
Or maybe a personal problem.
Right. A deeply entrenched conflict with a friend or a partner where you just couldn't see eye to eye no matter what you said. We get so locked into our single perspective, our singular set of measurements.
We get trapped, looking through just the red lens, completely convinced that our view is the only accurate representation of reality.
But what mathematics and quantum physics show us is that when you hit a wall, the answer is rarely to just push harder in the exact same direction.
Right. Don't just keep staring at the wall.
The answer might be to actively seek out the dual perspective. Try translating your work problem into its total opposite framework. If you are focused on the objects, try looking at the spaces between the objects.
I love that.
Or try looking at your personal conflict strictly through the blue lens of the other person's lived experience. Finding that dual translation, passing the problem through the mirror, might be the exact secret backdoor you need to make the solution obvious.
Recognizing that a single model rarely, if ever, provides a complete description of any complex phenomenon is really the first step toward actual understanding.
Which leaves us with one final kind of staggering thought to chew on today, something that SpiralSeekr's text dances around but leaves wide open for us to really ponder.
The big question.
The big one. We've established that our physics requires a duality to function. Our philosophy requires duality to make sense of the self. Our mathematics actively utilizes duality to solve complex equations. We completely rely on these binary frameworks to make sense of the universe.
Right, which forces a really critical, almost uncomfortable philosophical question.
Yeah.
Is duality an actual objective property of the universe itself? Like, is reality fundamentally from the ground up built on pairs and opposites? Or is duality just a hardwired biological limitation of the human brain?
Like, are we just permanently wearing those cheap 3D glasses and we literally lack the mental capacity to take them off?
Exactly.
Yeah.
Because if our brains evolved over millions of years to only understand things by splitting them into comparative categories, light and dark, wave and particle, mind and body, point and line, then maybe the universe is actually a completely seamless, unified, incomprehensible whole.
Just one giant thing.
Right. And we are simply incapable of perceiving it without mentally cutting it in half first.
Where is the boundary between the absolute objective truth of the universe and the biological limits of human perception? That is a question that will definitely keep you awake at night.
Oh, absolutely.
So the next time you look at a shadow on the wall, or a reflection in a window, or even just feel your own heart beating while you are lost in thought, remember you are experiencing one half of a massive dualistic architecture. Thank you so much for joining us on this deep dive. We'll see you next time.